is, let's go here. So in terms of a job in technology, we'll call it tech, 3 things that can be really helpful would be a degree, right? And that's a nice thing to have. And that's one, but also a portfolio project, which is what we're building. And then also a certification. And so what's great about this is that this is basically approves that, you know, you have you're dependable, you have some academic skills, right? And then a portfolio is really the proof, right? So in a portfolio, it's basically saying, you know, like, I can do this. So it's a demonstration of your skills, and again, a proof that you know how to do it. And then a certification is really a vocational component. So what this means is that you have been validated by the technology. And so you can, in just over the next few weeks, we could get all this done, right? So you already have this one, or you're on your way to doing this one. But again, most people, when they graduate from college, don't have these last 2. But if you build, just think about, you know, in terms of you were hiring somebody to work on your house, and you wanted them to put a fence up. At least for me, I would say, can you show me a fence that you did before? So I just see what you did. I think most people would want to see, hey, I want to hire you to do machine learning. Okay, well, show me your project. Show me the project that you put into the cloud, and show me, because I want you to do that for my company. So that's why this is so important. And then this one is very interesting. And again, by having access to these cloud labs, you can dive into this, is that it proves that particular technology, so AWS, Google Cloud, Azure, that you have followed their best practices, taken the exam, and then you are qualified to work on that platform. So really, these 3 are a very, very powerful combination. And what's great that about doing these is most people don't do this. So most people just stop right here. And so then you have a very substantial advantage if you have a portfolio and you have a certification. Okay, so let's get into the next thing here, which is, I'm going to call this cloud onboarding. And let me briefly talk about what that is, the cloud onboarding. So the first thing that just briefly I'll talk about here is, what is the cloud first? And this is an important topic. I think the best way to explain it is just with one symbol. It is the cloud is essentially the ability to have infinite capabilities, or near infinite capabilities, and that's why people use the cloud. So your laptop is not infinite. Like, your laptop is fixed. You can only do so much stuff. If you use pandas in your laptop, you could have big problems, because eventually pandas won't work. Or if you try to do high network bandwidth work and you're in a coffee shop, your laptop has to go back and forth. But with a cloud, you can do essentially, we'll call this near infinite storage. We also have near infinite disk I/O. So things like map reduce algorithms, and you also have near infinite network. So you can have 10 gig traffic going back between machines, and also CPU. And then I would say related to this is that you have platforms that are cloud native. And we'll say this is cloud native. And what's powerful about this is that you can assume that you'll always have infinite resources, and that the cloud platforms will, let's say several times per year, let's just say quarterly, that they'll get better. So you're basically, it's almost like buying an index fund. So you can think of it as an index fund. Why do people buy an index fund? Because over time, you'll get some rate of return, like 7% a year or 8% a year. Collectively, it's the same thing. By using the cloud native platforms, you know that they're constantly going to be releasing features over and over and over again. So that's really the reason for the cloud, and really the high level. So what are we going to do first here is that we're going to build an onboarding system for the cloud. And let me just describe it before I get into the code of it. So for cloud onboarding, let's describe the pieces that we will need. The pieces that we will need here would be a structure. So this would be a scaffold. And I use this for most of my projects, is in Python in particular, which Python really is the language for the cloud, most predominant language, because you can do machine learning with Python, you can do DevOps with Python, you can do software engineering with Python. Really, most projects in the cloud are probably going to be Python, although people do other languages like Go, Java, C#. But because of you can use Python with everything, why not just stick with Python? And the scaffolding for me for Python would be this structure, is that I would have a make file, and then I would create a script file here, which would be my source code. So this could be, hello.py. And then also you would have a requirements file, and this would be the library that I would use for my project. We'll say requirements.txt. And then also inside of here, we would have some kind of a test as well, and then a virtual environment, which I'll get into. And a virtual environment is a way to isolate your environment so that you don't get into conflicts with installing packages. So we'll just call this isolate. And then as well, this would need to run with a build server. So we're going to use something called Github Actions. And this is a DevOps process. And what this does is that it will, on an event, and we'll just say this is the event. So if you make a new change to the project, it will test your code. It will check it for errors, so syntax via Lint, and then it will do something to the code. And in some cases, it will deploy it, like in the Flask DevOps video. And where do I develop all this? So that's the scaffolding. That's what happens to it automatically, is you can develop it in a cloud native environment. And so we're going to get into that right now. But the cloud native environments, what you'll notice is that it can be a little overwhelming. It's like, oh, there's too many clouds. We've got Google Cloud, AWS Cloud, Azure Cloud. But once you understand that they all copy each other, that they're pretty much the same, and we're going to open up a shell in all three of these and then get this running. So over the next, let's say 45 minutes, we're going to get all three clouds you onboarded and familiar with how to write code and develop it using Python. And so let's do it. All right, so next up, what I'm going to do is I'm going to go to GitHub. That would be the first place to set things up. So I'm going to create a new repository from scratch here. So we'll go here and create a new repository, and we'll call this multi-cloud. So multi-cloud onboard. And I'll write a description here. This is a sample GitHub repo for doing multi-cloud onboarding. Works with AWS, Azure, and GCP. And this would work with probably any cloud. And we're going to leave this as a public repo. I always like to add a README file and add a git ignore for Python. So we'll type on Python. And all this does is it gives you the ability to ignore files that you don't want to check in, like virtual environments or .pyc files. And then I'll say create repo. That's it. And then once I create this, it's pretty much ready to go for me to start building things with it. And so I'm going to start with this one by one. So first I'll start with the AWS Cloud. So I'm going to go to a service called Cloud9. And what Cloud9 is it's a cloud IDE for running your code. And my recommendation is if you're doing cloud development, don't use your laptop. It's really a waste of your time because you'll be much more productive if you just start right in the cloud. And hopefully you'll see this, why it's more productive. So to create an environment as a student, you can, again, use this free. There's a free tier service, and we can just say, multi-cloud onboard project or something like that, and say this is a new environment for writing code in the cloud. And what's great about this is that it's going to put this inside of AWS, and so I can step away from my computer and it'll just save all my work, and I come back and then I go back and work on it. So it's almost like Google Docs, but for source code. And because it's inside of AWS, I can copy data back and forth without having to worry about a slow network connection. You could have an extremely slow network connection and use this, and it would be great. I would leave everything to default to start with. So this would create a new virtual environment for you. Notice here that this is free tier eligible. So this is ideal for students. And all you need is 1 gig of RAM and 1 CPU. And what's great about this as well is that it gives you Linux already installed with all the things you would need. Plus it has cost savings built in where after 30 minutes, it'll just time out. And so you don't have to worry about getting charged. So basically it's essentially free forever. If you use it correctly, you don't ever have to be charged for this. And then I'll go to the next step. So we'll go ahead and create this. And it takes 10 seconds or so to make this environment. So while this is getting set up, one thing I'll mention is that we're going to need to create SSH keys. Anytime you create a new environment from scratch, you need to create the SSH keys on the environment and copy those keys into GitHub so that you can do bidirectional encrypted communication without having a password. So really just once you set it up once, you never have to do it again. So I will show you how to set this up so that you see how to do it the first time. But once you've set this up, you never have to do it again. Unless you go to a new environment, and then you would have to set up a new set of SSH keys. But again, this should be pretty quick. Okay, so it's already set up here. Before I get into the SSH keys, I'll just show you a couple things that are useful about these cloud environments. One of them is that they give you a lot of the tools that you would already want to use if you're using the cloud. So for example, students that I see, one of the first things they want to do is put something in the cloud. Like I have a CSV file, I want to put it into storage. One of the problems is like, hey, how do I connect to the cloud? You can immediately do that. So from here, I could go like this, and I could say upload file, and I could just put something, and that's like the easiest way to put it in the cloud. And then I could copy the file. So I think I have like a CSV file on my desktop. Let's just try this real quick. If I go to, I think I have some NBA data. There we go, NBA data. I put it here. Now it's on my computer. There we go. I've got this. So this is now on the cloud. And if I wanted to, I can talk to the cloud storage via the the command line tools. So I can go here and say AWS S3 LS, and I could just list the buckets that I have. And then if I wanted to, I also could go through here and, for example, copy this to that cloud storage bucket, like whatever bucket I wanted to put. I would just say AWS, S3 CP, and then copy that into a bucket. So this is a huge asset, is that it just simplifies all the stuff that you typically would have to do when you first use a cloud. I don't have to worry about API keys. I don't have to worry about anything. I just can use this thing back and forth, also copy things between the buckets. So I just wanted to briefly talk about that. The other thing that's interesting is this environment has hooks into building code directly into AWS. And if I click on this tab here, AWS Resources, I can actually build functions that get deployed. They're called serverless functions into AWS. And I also can remotely invoke those. These are a whole bunch of projects that I've done. I could pull one in and build it as well. So there's a lot of great tools inside of here that really make it better than your own laptop. And I don't even use my laptop anymore to write code. I mostly just do it right into the cloud. Okay, so that's the very, very brief overview of this environment. So the first thing I'm going to do here is I'm going to create those SSH keys so I can talk to the repo. So I'll type in SSH keygen -t RSA. And I typically I think it's like 5 times I press return. I just say 1, 2, 3, 4. Okay, 4 times. 4 times I press return. And then what it'll do is it'll put a public and private key in my .ssh directory. And what I do is I type in the word cat, which is a Unix command that prints out something. And I'll just say, show me the public key. And the public key, I can grab this and then paste this into GitHub. So go back to GitHub and I go to my profile. So this name here, and I go to settings, go to SSH and GPG keys and say new key. Paste this in like this. And notice it starts with SSH RSA, and we'll say new AWS key. There we go. We add this, it asks for my password, and that's it. It's pretty straightforward process. Now if I go back to that repo that I just set up, which is called multi-cloud something. Yeah, multi-cloud onboard. I can click on this code icon, and I'll want to use SSH access, copy this, and then go back to multi-cloud and then check it out. So we'll say git clone. Let's just double check that. Yeah, okay, so we'll say git clone, and we'll put in that project. And because again I have those SSH keys set up, I can start writing code to it. And then I'll just cd into that repo so I can start working with it. So let's cd into multi. Great. So what I would typically do the very, very first time that I work on a project is have this essentially like a list of things that I would do. So why don't I even just write them down here? And what's nice about this is that I can go to this README file and I can maybe just put the list in here. So we can say, step 1 is create a Python virtual environment, and step 2 would be create a scaffolding. And what's also nice about this is it has all these tools that help me build code. Like it understands the markdown format, it understands Python, it understands JavaScript, HTML. So I have a really good editor as well. So I'll do step 1, create a Python virtual environment. What I typically will do is say Python 3 -m venv. And what this does is it invokes the virtual environment module. And I like to use this convention where I'll create the virtual environment as the same name as the repo that I created, and I'll put it in a hidden directory in my home directory. And the reason I do this is that I don't want to look at it. It's just something I need to use because the libraries will be installed in there. And then I don't have to remember what I named the virtual environment, because that can be kind of irritating. It's like, oh, what did I name a virtual environment? So I will say // and then I'll put that name in. right? And so if I always do this, then I don't have to remember what I call a virtual environment. And then if I use it, all I need to do is say source. So we'll go ahead and source this. And I'll show you really quick why you would want to do this. Hopefully this finishes. It's kind of okay. I guess it finished. So if I want to use it, I would say source tilde dot multi-cloud onboard bin activate, like that. And I believe actually these instructions are in the Git, the Flask project that I showed earlier, which I'll also just maybe put a link to in here, which is Flask. You can say this is a good reference. So I'll just put in here, we'll say this is, you can see a good reference here. Do this. There we go. So once I've done that, why would I do this? Well, the main reason is if I say which Python, now the Python lives in this directory and I don't have to worry about what else is happening. Like maybe I'm working on 3 or 4 or 5 projects, and it's very common that there'll be a project where I'm using scikit-learn or pandas, and then they change the version and then everything breaks. And then if I upgrade that version and then work on a new project, then I broke that project. And so you don't want to get into that kind of chasing your tail, essentially. If you have pets, you'll see your dog does that. So now that I've got this set up, I can create this scaffolding. And so, again, the scaffolding is pretty easy. It would be just, like a make file. It would be a source code file. We'll just call this hello.py. And then it would be a requirements file, .txt, and then also a... I think that's it. Make file, hello file, and then some kind of a test, and I think that's pretty good. That's about what we need. So I'll do that really briefly. I'll say inside of here touch make file, touch requirements file .txt, and then we'll say touch test hello.py, and then we'll also make that file as well. We'll make a hello file. So this is kind of a good basic structure here. Now for the make file itself, I typically will just copy what I do from another project. So I think if we go to this Flask project, for example, I can just copy some of this stuff. I can just go here and copy it, and I'll explain also what is a make file and why do I care about it. So one of the things that's interesting about a make file here is that the reason that you do this is the same reason you would create a bookmark in Chrome or Firefox, is that you don't want to have to go back to every website you visit constantly. And the same thing is, this is a lot of code to write, and it's boilerplate code, so it's useless code essentially. And so a make file allows you to build a command that wraps up some process. And so in this case, we can see that it runs this command called pip install, which upgrades the Python packaging tool and then installs packages. So now I don't have to remember all these commands anymore. I just say make install. Same with test. If when I want to write a test, I just say make test. And then also with lint, same thing. I just say make lint. And you can put anything you want. And you can put any commands you want inside of a make file. But typically for me, I do install, test, and lint are probably the 3 most common. But later, if you want to do a deploy, I also will put a deploy step. And then whatever cloud platform I'm in, I can just say make install, make lint, make test, make deploy, and I will go through and run all those. So for this, let's just start though with, let's start with the install command here. And the install command, we will need some packages inside of there. So I can go to here and put, for example, I want the PyLint, I want PyTest, and I think that's good. That's good enough. So this is a linting tool and a testing tool. And For the hello file, I can just do something really simple. I can just say like add and do X and Y, make it really simple, and return back X and Y. And we could just print add 1 and 2. So really simple function here. And if I run it, we can see that this just is some scaffolding, right? And I think for this, I want to say return X plus Y. Let's do that, return X plus Y. There we go. So this would return back 3. Okay, great. So I have a really silly, basic script here. And what I'm going to do is I'm going to say make install to install the Lint tool and to install the tests that I need. So we'll go ahead and do that. We'll say make Lint. I'm sorry, we'll run make install, which will install our packages. Okay, so now that those are installed, notice I can just copy this as well. This is something that I did from another project. Is my personal recommendation is that every project that you're on, most likely you want to have a lint step because it checks for syntax. Why would you not check for, and I'll show you why you want this, is if we go here and we say make lint now, you should see it, we have perfect, but let's say I mess it up. If I go back to this hello file and I put something weird in here, like I say var equals and put some broken code, it will catch that, right? So this is helpful just so it will catch broken code because Python doesn't have a compiler, and this is a way of protecting yourself from checking in code that doesn't work, especially on a team project, but even your individual project, like why check in code that doesn't work. So we have a basic structure here. This is good enough that I'm going to check this into source control now. And what I would do next here is I would say get status, and I'm going to check in readme, makefile, hello, requirements, test file. So let's go ahead and do this. We'll say get add readme, get add makefile, get add hello, get add requirements, and get add test hello. Looks pretty good. Commit this, adding basic scaffold. Perfect. And the first time you create a Git repo, it'll ask you if you want to put in the configuration information, which I'll do so that I can keep track. Let me go back in here. Occasionally you'll see here, it will ask you to log back in again. Just they have this auto log out. This is very rare that it happens that often, but if I go back here, I'll just log back in. Usually I think there's like certain time in the morning or something that it kicks you out, and then you have to log back in. Okay, so we're back in here. But actually there's a good test that shows you can start right back to where you were, right? Everything's the same. Nothing changed. So we'll go here and we'll put my name in here. So we'll say, give. And the idea here is that you can keep track of your commits according to your name, which is a good idea. So I would recommend doing this so that when you're working on your project, you can see who made the change to your projects. So we'll just go through here and we'll put in my email address. Okay. And then we'll username. Okay. Let's just do this. Put this in there. Didn't keep that for some reason. Okay, and then the final thing that they'll ask afterwards is you amend your commit so that it has that information. So you can put this in a configuration file as well, but I just do it this way. We'll write it out and then exit, and then we can do a git push. And then this will show up now back in the Git repo that I was working on earlier, which is this multi-cloud. It should show up and we should have a structure. So this is pretty close to being ready. So what I'm going to do now is I'm going to go to another cloud and then I'm going to check this out. So let's go to Google Cloud. And so this is the Google Cloud console, and it looks very confusing at first, like, oh, what is all this stuff? But they copy also AWS. They all copy each other. So I can just go here and say activate Cloud Shell. That's it. And if I click on activate Cloud Shell, what it will do is open up a shell that will be very similar to the AWS environment. So it's the same concept. Like, this is a great idea. I have something in here that sources a virtual environment, but you would do this essentially the same thing. Is you would create a virtual environment, create SSH keys, and even further, they have their own editor as well, right? So because I've already set up some of this earlier, I can just clone that repo. So I can just go back here and say code, copy this, go back to my Google Cloud Shell and do git clone, just like that. Multi-cloud onboard. I can CD into this multi-cloud onboard, and I also could have an IDE as well if I wanted to, and I also could create a virtual environment. So first I'll create a virtual environment so you can see the process here. So virtual environment tilde multi-cloud onboard. Notice that in this environment, they want you to install something first, which is because it's a managed virtual machine, which is fine. I'll just go ahead and install this. All right, so I installed the virtual environment package. Because it's your own cloud environment, you can do anything you want in Google Cloud. Now I'll run that command again, and it should work. And then I can source it. So it's very similar to what I have in AWS. And in fact, source bin activate, we can even verify, because I can do that make lint process, right? If I say make lint, we can see that runs. And if I say Python hello, we can see it returns back 3. And if I want to, I'm fairly comfortable with the shell, but if I wanted to use an editor, they have the same thing. So if I click on editor, it will actually open up a cloud editor, and you can do very similar things that we were doing with the AWS environment. So if I go here, I can actually go to this multi-cloud onboard and go to hello and just edit it in here, right? Or change the make file or do whatever I need to do. And then if I want to toggle back to the terminal, I just go back to the terminal. So this is one thing you'll notice with these cloud environments is they seem like they're complicated at first, but then they're actually almost identical because the people working at those companies go back and forth and they exchange ideas. So it's a very similar process. Now let's go to Azure, same thing. So if we go to Azure here and we first log in, we'll refresh here, that what we'll notice is that inside of the Azure environment, look at this, they have the same thing. They have the same button up here. So I just click on the Cloud Shell, it spawns a Cloud Shell, and then it would be the exact same process is create a virtual environment. Now, if you haven't done this for the first time, you do have to create an SSH key. So that is important to remember. But I've already created an SSH key, so I don't have to do it again. But what we'll do is we'll again clone this. So I'll just go code, copy this, go to Azure and say get clone, go like that. Multi-cloud, check it out. I could do the same thing. I could cd into this directory and then go Python 3-m virtual environment, create a virtual environment called multi-cloud onboard, and then source it and then make sure that my code works correctly. And you may be asking yourself as well with this environment, wait a second, I don't like the terminal although you should use the terminal in the cloud. It's really critical to use it, but also I like to use the IDE. If I click on this icon here, what this does, it also has a Cloud Shell editor. So we click on this and look, it's actually a very good editor because Microsoft makes Visual Studio Code, which is one of the best IDEs. And I can, again, go to this repo, go to my projects, find some code, and it knows exactly how to do syntax highlighting and everything, right? So it's pretty good editor as well. And in fact, I can even do split screen here. So I can say, make lint as well. And so in this case, this didn't work because I didn't do make install. So I need to say make install. And this will install those packages. So that's one of the other things that you would want to do when you first create an environment is clone it, or actually first make sure you have SSH keys set up, then clone your project, then create a virtual environment, then install it, and then you're pretty much ready to go. And I would lint your code first to make sure that it works properly. So if I say make lint, we know that works. And if I say Python and run this script here, that works as well, right? So now that I've got all three clouds set up and it was fairly easy, one piece that we're missing is the robots. And so this is something that's critical in the cloud, in this environment, is why would we do this step here? This GitHub action is really, this is a robot. This is what we're building, is this robot. And I think everybody now, to some degree, likes, I don't know how to make a robot head. Maybe that's a robot. But basically, every time I do anything, I can have this build server test all those things I'm doing for the command line. Why wouldn't I automatically do that so that I always know my code is good, it's linted, it's tested? So that's what we're going to do next, is that I'm going to go to this environment and I can set up an automation process that always validates that my code works. So how do we do this? Inside of GitHub, there's something called GitHub Actions. And if I click on this icon, what it will do is it will allow me to set up a workflow. And it could be anything. You could do any kind of automation, but I want to just make sure that my code works every time I check it in. So I'm going to click on set up a workflow. And it's pretty easy actually to put something in here. And so I'm going to copy a project. I'm going to find a project that I already have something inside. And I think I have like a PyTest project here. PyTest. Yeah, here we go. GitHub Actions PyTest. And I'm going to copy a workflow I had set up earlier that does pretty much what I want. So we'll just go here and I can put this inside of my other GitHub workflow example. So let's throw this in here like this. So this is a Python application test with GitHub Actions. Notice a few of the things here, that this is the Docker container that we would run on. So in this case, it would run on Ubuntu. I could tell it which version of Python to run. Python 3.5, 3.6, 3.7, 3.8. Sure, let's leave it Python 3.8. This make install step here, this would just install the software. So I could always test that my software is being installed properly so that I know when I clone this project, the packages will always work. I could also go through here and say make lint. I could also go here and say make test, which we'll do in a second. And I also could even format my code if I wanted to. So sure, let's try this out. Let's create a commit here. And if I commit this, we'll say create automation with GitHub Actions. Say automatically test my code. We'll go ahead and commit this. And when you commit it, it will try to run all those. Now it's not going to work because a couple of those I don't have set up yet. I don't have the test set up and I don't have the format set up, but we'll fix that. But let's go to the actions button here and you'll see it running. And inside of this, we have run actions, set up Python 3.8, install dependencies, test your code with PyTest. So we see that it failed already, which is really nice, right? Because I can go inside this console and it shows me exactly what the problem is. Oh, there's no format rule. Okay, great. Well, how do I fix this? Let's go back. It doesn't matter where I fix this. I'm going to go back to AWS though, and I'm going to do a git pull, which it'll pull down this new information. So we'll say git pull, and you'll notice it just puts the GitHub workflow here. So if I wanted to edit this inside of here, I could edit it inside of here. All I need to do though is add a test and a format section here. So I'm going to go back to my makefile, and the test section, let's actually make it do a test for this hello file. And then I'm going to say test hello. So this, what this says is run the PyTest test framework and also do code coverage using a tool called PyTest Cov. And then here's the test file. So I'm going to add that library called PyTest Cov. PyTest Cov. I think that's how you do it. I can double check though, because let me see what the name of that file is in my other project. Let's see, PyTest. I can Google it. Be lazy. PyTest Cov. What is it? What is the library? Yeah, it is a hyphen. Okay. I just want to make sure I got the name right. It looks like, there you go, PyTest Cov. That's all I needed. Okay, so now that I've got that, PyTest Cov, I can write a test file, so I can go back, save this, do a make install so that it installs this new library, go to this test file, and it's going to be a pretty easy test. I just say from hello import add. I don't even have, I think from memory I can do this, and just say def test add, and then I just assert something, like I just say assert 3 is equal to add 1 and 2, right? So make sure that when I call this function that it actually works, right? That's the whole point of a unit test. And now I can say make test, and it should work. There you go. And it shows me how much of the module actually has tests associated with it. So it's 100% because it's a very small module. And I could test that it's actually working properly by making it fail on purpose. And I could run it again, and this should fail. There we go. So we can see that 4 does not equal 3, right? So I'm going to change it back to 3. Okay, so we got that working. So I have inside of this project the install, the test. Oh, but we needed a format, so let's add a format step. And there's a neat tool in Python called Black, which formats our code so that it looks like professional code. So I'll type in Black, and then I'll do .py just like this. And so I need to install that library as well. So go back to this requirements file, type in Black. There we go. And if I do make install here, that should install that. And then if I say make format, this should format it. Woo. I don't know what that is. Preparing. Well, it looks like this library, which is optional, blew up, which happens sometimes. And so I'm going to say I don't need that because it's an optional thing to have. And I'll go back here and just take this out. Just say, I don't want this. And then I'll also go back to that other file here and say, we don't need this step, right? Because really the core steps I would say are install, lint, and test. The format is nice to have. Okay, we got that working. Let's again say make all, which will install, lint, test. All that works great. So I can do this. I can say get status, see what the changes are, and push all this back to GitHub. And this should fix the error. So I can say git add .github directory, GitHub, and then git add the make file, git add the requirements file, and git add the test hello. And if I say git commit, fixing GitHub Actions build, we can do that. And although I should probably, yeah, good, I got all that done. So if I go back to this project now, it will rebuild this, and you'll see it that there we go. So it's rebuilding it again, and it's going to do exactly what we told it to do, which is it's going to install, it's going to use Python 3.8 in Ubuntu. It's going to install our dependencies. It's going to lint the code with PyLint, and then it's going to test it. And if all of those are successful, it'll show that it was successful. So this is extremely helpful. I would say every project you should do this on. And we can even go here, which I think there's a section. We go here, and you can create status badge, and we can copy this as well. And then we can go back to our project and put this in the README file, so we can build a neat badge as well. So this badge will show us the status of the project. So then other people can see, we'll say adding status badge. There we go. So other people can see that, hey, my code actually is working. And this will I think fix once it runs once. So now that I got this working, what I can also do is let's test it on Google Cloud and Azure real quick to make sure everything works. So I'm going to go to Google Cloud and just say git pull. So make this a little bit bigger. So I'll say git pull. This should pull those changes in, and I can also just say make all. There we go. And let's see, does this work? So it installs it, and then it's going to, after installation, it will lint it, and then it'll test it. Everything works. And then if I go back to Azure, same thing. I just say git pull. It should pull these changes in, and then I can say make all, and it'll do the same thing. It'll install it. It will lint it. It'll test it. Everything works, right? So this is the multi-cloud onboarding, which is that now I can start. So why would I do this? The reason for this is I have automation. I also have the ability to write code on any cloud platform. In some cases, you don't need to work on all three clouds at the same time. But it is nice to be able to build a Flask app or a command line tool or something like that, and you really can run it anywhere, and it's fairly straightforward, especially if you go through here and you set up this, multi-cloud type environment. So this is probably a good place to stop here.